I will promise you that this will not be boring one way or another. I'm going to have, of course, live demos, but there might also be stuff that fails and I have to explain away or explain in more detail. There's going to be 2 demos. I think one is very relevant because it's going to be very much in line with what OpenAI has just released with the agents and your personal agents and kind of computer use agents. So we're going to look at the demo for that. And then we're also going to look at a demo. How could there not be an MCP server? But that's kind of secondary to the overall demo. So those are the 2 demos I have. And then, of course, there's going to be, I'm a PM, there's going to be a pitch up front. I'm going to give it another 2 minutes before we get started. So yeah, stay tuned. Actually, screw it. Let's just get started. All right, so I am Simon. I am working as a PM on Azure Container Apps, and today I am going to go and talk about a feature of Azure Container Apps that is a companion feature called Dynamic Sessions. But before we dive into that, I'd like to talk about Container Apps for just 5 minutes. So Container Apps, I like to think that Container Apps, this is different than any other service that Azure has or many of the other services because it is actually a developer-first service. We want developers to be happy. We want developers to be highly productive. And as a result, we offer kind of a core set of features. Number 1, we're serverless. Number 2, I already received the question before even starting the session. We allow you to scale from kind of, in all kinds of scenarios and adopt that. So we can scale from 0 to hyperscale very seamlessly. We're a fully managed service, which is a somewhat overused term, but that basically means that DevOps is included for us. And then we have a set of curated building blocks, one of which we will talk about today. Let's quickly talk about what it means for Container Apps to scale seamlessly. I actually just received this question. Thank you very much. I owe you a 6-pack. If you are in an innovation stage and you kind of have, really no users or very few users, maybe it's just you and your team, maybe a couple colleagues, and you really don't want to incur any costs at all. Container Apps actually accommodates that. We have a very limited, free tier as well. You can basically provision a container and basically run an app with kind of small endish traffic and incur very, very limited or no costs at all. If this application then, happens to scale, you can go, for example, a mature internal app. You have a user count that's in the thousands, maybe a few hundreds. You are mature that really you just need a place to host this and forget about it, basically. We have a pay-as-you-go model. So that means you can just run, you don't have to reserve instances. You literally just pay for what you're actually using. We have both idle as well as, use billing. Our billing works on recept, and we have scaled to 0 as well. So you can run an internal app, kind of set it and forget it with very minimal costs, and essentially no administrative fees at all. We're going to talk about that, or tax, so to say. And then, if you're full-scale SaaS, oftentimes, running a platform is a distraction, right? And so you're looking to really, deliver features to your users. And so, if you have a user count in the millions, and maybe this is a greenfield app where you're very rapidly iterating, we actually also allow you to run a reservation-based model like, a Kubernetes service would or any other services where you just pay for a reservation and that basically gets used. So that's what it means to scale from 0 to hyperscale. And then what does it mean to be fully managed, right? So all of the stuff that oftentimes a DevOps team kind of curates and builds around the platform, the core platform, we actually that's included in the product. So it doesn't matter if it's the platform upgrades, the CI/CD pipelines, revisions, scaling and monitoring. basically, when you're using Azure Container Apps, all of that stuff and the team running the service for you actually becomes or an extension or becomes your DevOps team. And then lastly, those are the curated building blocks. Because we want you to be, focusing on features, delivering quickly, we have built-in authentication against GitHub, Facebook, Google. You can run your functions. If you have like a set of companion functions that you want to maybe run in the same place and not worry about networking or any of those other concerns, you can run those. We have jobs that allow you to run, batch or micro-batch kind of workloads. We have a set of managed components for both Aspire as well as Java Spring. And then lastly, we have this new feature, which is very kind of tinted in this AI framework or in this AI first future, which is called dynamic sessions, which we're going to talk about next. That's essentially the entire talk from this point on. So what is dynamic sessions? Basically, dynamic sessions are a set of sandboxes that allow you to, run untrusted code, meaning code generated by AI, maybe code generated by your users, maybe code generated by, anyone, documentation, comments, anything like that in a fully isolated Hyper-V barrier. This code executes in milliseconds. Our P90 is below 100 milliseconds. Our P50 is below 50 milliseconds. These are very aggressive numbers, and it's kind of awesome actually. So, and then lifecycle management. Again, in the spirit of container apps, it's a set it and forget it. Other than creating a pool of resources and basically utilizing that pool through a REST endpoint, there really is no other work that you have to perform to keep this thing running. We automatically delete the sessions for you after some timeout. We automatically maintain the pool for you. Once it goes and, grows beyond a certain limit, it automatically gets scaled out, and so on and so forth. And it's a highly scalable service. So this is actually being used internally or actually visibly as well. If you go to Bing and you basically ask Bing to do some math for you, that actually gets kind of shelled into a dynamic session and then returned back to you. So, how does the dynamic session work? Basically, what you're looking at here on the right-hand side, or yes, you're right, is essentially a session pool. You provision a session pool. A session pool has a certain size. That's the number of sessions. Those are the individual boxes that you see there. And then essentially what you're doing is you're just accessing that session pool and you're passing the code that you wanted to execute into the session pool, and you get allocated to the same session by using the same identifier. Very straightforward. I sometimes also like to think of this as a functions pattern that comes to your code rather than your code coming to functions. Meaning, if you have a portion of your code that's, heavily multi-threaded, needs to run on some endpoint, or otherwise you don't want to be worried about scaling or any of that, sessions is also a perfect solution for that as well. And so let's take a look at actually, before we dive into this, let's take a look at what a session pool looks like. So hopefully this is somewhat, yeah, okay, cool. So I've created a session pool in here. There is an endpoint. I'm going to be using this endpoint to basically go and do all my interactions. I append a certain set of REST paths to the end of this pool, and then I can execute whatever I want. So for example, if I want to execute against this session pool, I would just add /execute, pass the payload as a post, pass an identifier, and then the code would immediately execute and return. There are a set of pool types. At the moment, we support two different kinds of pool types. The first one is a Python tool type. That means most LLMs generate Python code. When you go and ask an LLM to generate some code, most likely, unless you prompt it otherwise, or it sees that that's clearly something else you want to do, it generates Python by default. That's why this is a Python interpreter or Python session pool type. This means that this pool type executes Python. I know that's probably less exciting to many of you. We have a secondary session pool type as well. It's basically a custom code interpreter. So you can bring your own kind of container. There's a set of requirements that you have to fulfill with that container, but then you can give that container to us, and you can make your own session pool with your own style container. So if you wanted to go and run uncompiled .NET code, or maybe submit .NET code to the session pool and then have that code execute, compile and execute, that could be accomplished. At the moment and behind the scenes, this actually is a Jupyter environment. So, like if you're familiar with the Jupyter notebooks, you can kind of have a web interface that allows you to specify code and then, run that code right there live in real time. That's essentially what's running this session pool at the moment. And then there's a playground, right? So like very easily, the simplest kind of method here is, let's do hello world. I can run this code, and you can see, boom, whoop-de-doo. This did a round trip. It went to the session. It executed that code. It returned us the result. You can see at the top there is a, hold on, buddy. At the top there is a session pool identifier. I can say, put a different session pool here. And then I can, for example, run, and we're going to go revisit this as well, run the same code again. Whoop-de-doo, it's hello world, but you get the idea. It's not the same session anymore. It's a different container that it just gets executed into now. So let's go to our demo scenario. We've got 10 minutes left. So here in this demo scenario, some of this will work. Some of this might not work. Those AI demos are always a little touch and go. But basically what we have is we have an MCP server that uses sessions behind the scenes to execute the code. And we have a front end. In this case, it's just a typical like chat app that basically go back and forth, boom, boom, boom. And we can then see what happens when we interact with that. So let's do that. Yeah. So I think I switch over to this one. There we go. So this is my app. I'm going to show you really quickly. I don't know who in here has heard or done anything with MCP before. Just show of hands. Okay, cool. All right. So MCP by default is a standard in, standard out protocol. So I learned this as part of this exercise as well. So this isn't quite as clean as I had hoped. I was hoping that there was like a local TCP connection, but there is not. So the GUI actually instantiates the server behind the scenes whenever there is the need to execute a code. So let's get going. So I have this just, let me make this slightly bigger. Yeah, maybe. Okay, I'll just tell you right away. The upload files does not work, but we can still take a look at this. So let's check if we're wired up. Okay, cool. So now, again, this is wired up to an LLM. I'm using an OpenAI endpoint, right? So this is basically just the regular chat stuff. This is not sophisticated. I'm not parsing context, and so there's no history. Very dumb, but you'll get the idea. And we'll look at the backend as well as part of this. So let's just start with something easy. Yes. And I don't know if that will actually now be, no, thank. See, I'm not there it is. Okay, cool. So I know, we're going to look at the backend here in a second. But basically, you can see, can you do a hello world? Okay, boom, it generates the code. I could have also said something more complex, and it would have likely generated the code right away. And then it asks me, do you want to run this? And then yes, it runs it, and whoop-de-doo, we see hello world. And what we can now look at here is, we'll look at the backend, and you can see that it's actually going and executing the code, right? You can see kind of the management URL that I showed you earlier, and then it appends code execute, and then it submits the payload. As you can see, it's print hello world, and then it gets the output back in standard out hello world. So great, it works. So what can we do with this, right? Again, this is a very simplistic, yes, vibe-coded app, but you can do some really cool stuff. So let me play. There's almost going to be certainly some failures to it, but so I'll start with this random CSV file that I basically found. And it may, let's see, there we go. So you can see, right? Basically, it executes this formatting, could be better. Maybe it's also my browser is slightly off. So I downloaded this code, generated the code to do so, and then parsed and showed me the top 5 results of this file, right? If we look at the back end, we can actually see, my server died, but we can basically see that it generated the code. So if you took a look at, again, this is the payload that was generated by the LLM, and this right here is the code that was generated, right? So it imports requests, which is the library used to do essentially the request. And then it imports pandas, which is a very popular Python library to manipulate CSV and data files. And then it actually comments, nicely enough, it comments that, hey, let's use this as the URL. And then it actually goes and gets this URL right here. I wish I had this better formatted. And then it basically reads this CSV file, and it shows you the top 5 rows. And those then get returned in the output right here. So that's the first demo. Cool. You can kind of see where this is very useful in a scenario where you're trying to cater to maybe business users to discover, manipulate, get insights in combination with an LLM, where you don't want to give them access to the keys. If you were to run this on a local system, I could also ask and I didn't incorporate this into this demo, but you could ask the LLM for like the API access key, and it would likely tell you because it's right there, right? So this basically prevents any type of, leakage or other credentialing. It gives you a secure enclave to run this code in without having to worry that there might be like a reach beyond of what it's allowed to do. So first demo. Second demo, I have this, and this is going to probably go us beyond. So we're going to just kind of watch this because my time is running out. But this is a computer using agent. I don't know if you've used the kind of the agent functionality. Computer using agent is essentially a combination. It's a specialized model that's actually publicly available by OpenAI. But then Azure Foundry also hosts it as an API endpoint. The computer using agent model basically, as the name suggests, uses a computer. So the most direct view of this, and we're not going to go and look at this in a whole lot of time because I'm actually running out of time again, but you can see I can, if I run this locally, then this looks as follows. You run the agent. This is how you instantiate the agent. The agent launches a browser, and now it's awaiting kind of like, hey, what do you want me to do, right? So let's tell it what to do. And then we can kind of just, do its thing. It is not the fastest, especially when you're running it. Oh, let's see. No. Oh, there you go. Okay, I think it's going. Okay, cool. So we can kind of watch this, and I can explain to you what we're going to do next. So this is the computer using agent running locally. You can imagine that this is an enormous potential for all kinds of things, right? Like I could ask it to basically, like if I didn't launch it with Playwright, but kind of gave it access to the entire system, I mean, the world is your oyster, and all kinds of things could happen. With what we're going to do next is we're going to actually launch this, but launch it within sessions. So rather than running it locally on my system, I'm going to launch it in sessions. So you can see, boom, 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 it did the search, it did the query, and then it told me, oh, the weather in London at the moment is 70 degrees Fahrenheit, right? Pretty cool. And that's actually the tech that's being used behind OpenAI's agents as well. So we're going to close this, and then we're going to launch this not locally, but with sessions. And so now I'm using this Python interpreter to launch Playwright, to launch Chromium, to then provide it instructions on what to do. So this takes a slight bit longer because, again, it has to launch the browser there, and then it has to kind of initiate the entire system. But I'm getting a prompt. Again, you can see I'm not running a browser, right? No rabbit in the hat or anything like that. And then we can ask it a question again. Let's do this one. And I'm being very specific in my queries because it cuts down the time that it requires to do searching and submitting and all of that kind of stuff. So you can see, and we're going to revisit this. So I'm going to copy this session ID. But if we take this session ID, and this kind of touches on another subject here, you can see it's generating the screenshots, right? So sessions also, they don't just execute code. You can actually upload files, download files. And so these files that it currently generates in the form of screenshots are basically screenshotted into our session for later access. There's also a log. The system has a log at the moment, so I could take this session back down and kind of show you the browsing experience and what it went through. But you can see it's submitting a query. This is where it's typing Hacker News. And it's taking a screenshot to make sure it understands where it's sitting. And then I'm guessing in the next minute or so, we're going to go and get the top post from Hacker News. And to make sure that I'm not making this up, oh, look at that. How fitting. GPT-5 was released. So let's see what it says. All right, that's all I had. I think I'm sitting like I'm open for questions. I know this was probably a fair number of things rushing down. That's, I guess, why this is called fast focus. Maybe there's some questions. Maybe there are none. I'm here. I'm also outside later.
Is there a way to, if you wanted your code to execute on a session, could also pass through? So let's just say that you have some hardware device that you're trying to interact with through this Python code in your session. Is there a way to do if I connect my device to my computer, can I cast that to the session so that you communicate with this device through the session?
Let me see if this, I mean, of course, the devices are not connected to any of the session devices, right? So the way I would address that is probably through having an MCP server or some other means to extract whatever you need from the device, be it, I don't know, the binary, I don't know what device we're talking about, but be it the binary blob or the audio, whatever you're basically looking at, and then essentially pass that into the session alongside the code that you wanted to execute, and that would work very well, yes. You could upload it, or you could pass it as part of like the code, like base 64 encoded, take this and basically take this input and decode and do whatever you need to with it, yes. You can think of the session as basically like a Jupyter notebook, because that's what essentially it is. Only that you don't have web access, you only can interact with it through kind of the REST endpoints that are available. See, it's still browsing. In the meantime, while this is going on, I can show you some of the details around like downloading a file. You basically just look for dynamic sessions, and there should be plenty of information that you have on hand. Any other questions? Cool. All right. Yeah, so Azure Container Apps, dynamic sessions. Azure Container Apps is a developer-first service. If you just want to go and produce results and host your app, Container Apps is a great option for you. Thank you all for coming. I'll talk to you guys later.